Welcome back. Today we're going to talk about constant rates of change. And the thing we have to remember about constant rates of change is the rate of change still has to do with that mentality of per, miles per hour, things like that. Constant means they don't change. So it would be as if we were moving at a constant speed or something like that. Let's talk about a giant tortoise. A giant tortoise moves at a slow but steady pace. Steady meaning unchanging. So the pace is steady. We're going to assume that it's unchanging or that it's constant. Okay, so if it's at a constant pace, it takes it 3 seconds to travel 10.5 inches. We're going to assume it didn't travel all 10.5 of them in the first second and then stop. We're going to say it traveled the same amount each second. In 1 second, well, I have 3, so what I'm going to do is I'm going to say I want per 1 second. So what I need to do is I need to take my total distance and divide by my time. So distance over time equals, so 10.5 divided by 3. Well, if I look into that, I'm thinking to myself, okay, if I've got 3 times 3, that'd be 9. So it's 3.5 inches per second. And that slash means per. Okay, so that's a constant rate. We're saying each second it traveled the same amount. And so the extension question on that is, it didn't travel for 3 seconds. What if it traveled at that speed? So that's the kicker. At the same speed for 12 seconds. Well, in 1 second, it travels 3.5 inches. So if I need 12 seconds, it'd be 12 sets of 3.5. So it would be 12 times 3.5. 12 times 3 would be 36. Plus 0.5 times 12 would be 6, would be 42 inches. So how would I describe the rate of speed? This is a very open-ended question. Some of you might say slow. That is very slow. But what they're looking for is constant. It's not changing. It's not, this tortoise is not sprinting and then walking and then jogging and then walking and then walking and sprint. No, constant rate of change. Same. This ties into proportional relationships. Proportional relationships have to do with the rate at which something is changing. So the rate of change is a rate that describes how one quantity changes compared to another. So for example, the rate of change might be miles per hour. The word per is key. We're going to have per in rates because it's going to be per time. So dribbles per minute, fouls per day, whatever it is. A proportional relationship between two quantities is one in which the rate of change is constant. That I can't even highlight that enough. The rate of change is constant. It's unchanging. It stays the same. Okay? The rate of change is constant. This is the big idea here. Has to stay the same. And so the proportion down here is a statement that two rates or ratios are equivalent. What does that mean? For example, if I travel 100 miles in 2 hours, that's equal to traveling 50 miles in 1 hour. It is also equal to traveling 150 miles in 3 hours. So these proportions are equal. We're saying the proportion to rates or ratios, read that, fractions, which I know some of you are like, oh, fractions, I hate them. But this is really what this is. It's a per statement. It's saying the rate is the same. Here's an example. Callie earns money by dog sitting. This should be based on the table. It is the relationship between the amount Callie earns and the number of days a proportional relationship. Well, let's look. If she dog sits for 1 day, she gets $16. So one day, $16. So we could say 16 per day. What about 2 days? Well, then we're saying, okay, it's $32 over 2 days is equal to 16 per day. $48 for 3 days. Well, 48 divided by 3 would give me $16 per day. Notice, so far, 16 bucks per day each day, regardless of the number of days so far. So that's a key thing. What about 64? 64 divided by 4 is going to be $16 per day. And guess what? $80 over 5 is 16 per day. Notice, I kind of wrote this one backwards. This should be $16 over 1 day. Well, look, these are all equal to each other because they're all equal to $16 per 1 day. So yes, the relationship is proportional. It is proportional because all of the rates are the same. So we could say that, yes, it's proportional. Rates are the same. So the rates are the same. Here's one it says for you, but we're going to do it together. The table shows the distance Allison drove on 1 day of her vacation. Is the relationship between distance and the time a proportional relationship? Did she drive at a constant speed? Well, miles in hours. So 65 miles per hour. Then 120 for 2 hours equals 60 miles per hour. Well, notice, these are not the same. These are not equal. So it's not proportional. The rates differ. She drove at different speeds. That's okay, but it just means it's not proportional. When we do have a proportional relationship, for example, that $16 per day, 16 is the constant of proportionality. That's the constant of proportionality because it's 16 times the number of days. So whether I did it for 3 days or 18 days, it doesn't matter. The rate is the same. That's the constant of proportionality. So you might ask yourself this question, or this might come up in your grocery shopping if you want to buy a lot of cashews. Okay, these are cashews. I've got 1 for 19 or 4 for 76. What's the better deal? Well, if I've got $19 per can and I've got 76 per 4 cans, I got to ask myself, well, what is 76 divided by 4? If you do that math, 76 divided by 4 actually ends up 19. So these are the same. So I could say, hey, how much those cashews cost? Oh, they're 19 bucks a can. So whether you buy 4 or you buy 400, $19 a can. An extension question. If we said it was 2 pounds for $19, 8 pounds for $76, we've already determined. So if I've got 19 for 2 pounds. We've already determined that up top they were the same deal, but let's do this. What if I didn't want that much? What if I wanted 3 pounds instead of a denomination of 2? So I've got this, and this would be $9.50 per pound. Well, it's going to be the same over here. 76 over 8 is equal to $9.50 a pound. Well, based on that, how much would 3 pounds cost? Well, if I know how much 1 pound is, how much would 3 pounds be? Well, 3 pounds would be $9.50, and you see this when you go to the grocery store or whatever. Hey, this meat is priced per pound. Well, how many pounds? I got 6 pounds. Okay, 6 times the price. So $9.50 times 3 is going to give me my amount. So 3 times 9 would be 27, plus 50 cents times 3, which is $1.50, equals $28.50. You're probably thinking to yourself, man, those are some expensive cashews. But cashews are delicious. Remember that. Let's do this one together. School field trip. There must be 1 adult to accompany 12 students, 3 adults to accompany 36 students, 5 adults to accompany 6 students. I'm going to write this out. 12 to 1. Is that equal to 36 to 3? Is it equal to, and these question marks mean, hey, I don't know if they're equal, are they? 60 adults to 5 students. Are those equal? Well, yeah, 12 over 1 is equal to 36 divided by 3 would be 12 over 1. 60 is a little bit tougher. 5 goes into 60 12 times, so it's 12 over 1. So yeah, those are equal. So let's see what they're asking. Show that the relationship between the number of students and adults is a proportional relationship, then write an equation for the relationship. What they're saying is this. Is it proportional? Yes. It's always 12 students to 1 teacher. Okay? So what they want to know is write an equation for the relationship. Well, basically they're saying, well, how can I figure out how many students there are, how many teachers? Well, if I take students, number of students, divide by 12, it's going to give me number of teachers, right? So I could say number of students divided by 12, that would be number of teachers, or number of teachers times 12 equals number of students. Okay, that's basically how that works. We've got unit rates, it's per 1. So if you can figure out how much 1 costs, you can use that to multiply to get each individual value and figure out how much another amount would cost, or how much another amount of teachers you would need, or something like that. Okay, thanks for watching, guys, and we'll see you next time.